Hello students, let me discuss some important points regarding to the laws of motion objective point of view for JE, NEET and CET level. So linear momentum and change in linear momentum base P is equal to linear momentum P is equal to m into V, whereas Newton's second law of motion, force is equal to rate of change of momentum and F is equal to m into dV by dt plus V into dm by dt. For constant mass, force is equal to mass into acceleration. Impulse is nothing but force into change in time interval, which is equal to change in momentum delta P. And based on this we got even 2021 July session. For a variable mass system, force is equal to V into dm by dt, where dm by dt is nothing but rate of change of mass and force required to hold a force by F is equal to rho a V square, where rho is density of the liquid or water and A is the area of cross section, V is the speed of the water flowing through the pipe. Force needed to hold gun, which is F is equal to nmv by T. N represents the number of bullets, V is speed of bullet and m is the mass of the bullet. In equilibrium, net force acting on system is equal to 0. And Lami's theorem, based on that equilibrium also we are getting so many problems. So according to Lami's theorem, if the force number of force acting on that one, then force by opposite sine angle, so F1 by sine alpha, whereas F2 by sine beta and F3 by sine gamma are same. So F1 by sine alpha is equal to M2 by sine beta is equal to F3 by sine gamma. So acceleration of the body in a lift upward direction, then the net force is equal to m into g plus a, and if it is in downward direction, net force is equal to m into g minus a, and lift is moving with uniform velocity, acceleration is 0, then the net force is equal to weight, and if the lift falls freely, acceleration of the body is equal to acceleration due to gravity, then net force is equal to 0. Whereas bodies connected together, m1, m2 and m3, now force acting in this direction, net acceleration A is equal to F by m1 plus m2 plus m3, whereas the tension between m1 and m2 is equal to m2 plus m3 into A, means what masses it has to pull, m2 plus m3, so that tension is equal to T1 is equal to m2 plus m3 into A, whereas tension between m2 and m3, this string should pull m3, so that T2 is equal to m3A. By taking net force equation you can get this. In a towards motion, very important topic, and acceleration of the system, greater mass minus lower mass by total mass into acceleration due to gravity, and tension is equal to T is equal to m1 m2 by m1 plus m2 into g. Whereas acceleration on double inclined plane, you can see here, then m2 sin alpha, m2 sin beta minus m1 sin alpha into g by m1 plus m2, whereas tension is equal to, so here 2, instead of 2, if you have taken sin alpha plus sin beta, you will get the same, which is m1 plus m2 into sin alpha plus sin beta into g by m1 plus m2. Whereas on smooth inclined plane, acceleration of the body V is equal, A is equal to g sin theta, and velocity when it reaches to the bottom of the inclined plane, V is equal to root over 2al, which is 2g sin theta l, which is equal to root 2 gh, and time taken to reach bottom of the inclined plane, T is equal to root over 2l by A. So friction force, static friction, kinetic friction and rolling friction. Fs is equal to mu Sn, Fk is equal to mu Kn, and Fr is equal to mu Rn. So static friction is always greater than kinetic friction, you can see in graph. Angle of friction is equal to the angle between resultant of normal reaction and friction force with the normal reaction is called angle of friction. Now quotient of friction is equal to mu is equal to tan pi, and R is equal to root over f square plus n square. So on motion of the body on rough inclined plane, first to find the nature of the friction, first we have to calculate limiting friction value. Mu s is equal, Fl is equal to mu s into n. Now if the applied force is less than limiting friction, nature of friction is static, and static friction is equal to applied force in this case. But if the applied force is greater than limiting friction, nature of friction is kinetic, and Fk is equal to mu Kn, then net force is equal to F minus Fk, and acceleration of the body is equal to F minus Fk by mass. when a body is sliding on a surface, in that case with initial velocity u, then acceleration is equal to minus mu k into g, and s is equal to stopping distance u square by 2 mu k g, whereas time taken to stop this object u is equal t is equal to u by mu k g. When a chain hanging from the table, a part of 1 by nth of the length of the part of the chain is hanging, then the fraction of the length of chain hanging, which is 1 by n, that is equal to mu s by mu s plus 1. So where mu s is the coefficient of static friction between chain and the table, and from this one mu s is equal to 1 by n minus 1. N represents, for example, if 1/3 of the length is hanging, then n is equal to 3. 1/4 of the length of chain is hanging, n is equal to 4. Then mu is equal to 1 by 4 minus 1. Mu is equal to 1 by 3, 0.33. Based on this one, in 2023 JMN, we got the problem. On rough inclined plane, if the body is moving up the plane, then minimum force required to move up the plane, mg into sin theta plus mu cos theta, whereas acceleration of the body a is equal to g into sin theta plus mu cos theta. Whereas down the plane, force needed to prevent sliding, f is equal to mg into sin theta minus mu cos theta, whereas acceleration is equal to g into sin theta minus mu cos theta. Whereas time taken t is equal to tau 12 by a1, but when it is sliding down, time taken to reach the bottom of the incline, t is equal to root over 12 by a. A is nothing but here g into sin theta minus mu cos theta. In 2023 JMN even 21 also, based on this comparison of the times per rough incline up the plane or down the plane with comparison of the smooth surface given. Whereas in circular motion, so friction force must be equal to the centripetal force, which is F is equal to mv square by r or mr omega square. So the maximum speed, safe speed to take a turning without skidding is equal to root over mu s rg. But on a banked road without friction, maximum safe speed is equal to root over rg tan theta. So angle of banking, which is tan theta, is equal to v square by rg from this one. And with friction on banked road, to avoid the skidding up the plane is equal to v is equal to, you can see that v maximum is equal to rg root over rg into tan theta plus mu by 1 minus mu tan theta, whereas down the plane maximum safe speed v is equal to root over rg into tan theta minus mu by 1 plus mu tan theta. And dear JE and NEET and CET aspirant students, please go through this and to get success in your respective exams and very important topic of this laws of motion. Thank you.